Hello everyone. We are doing a project on movie recommender system with some regression analysis and classification. Our team comprises of me, Eric Park, and Denver Gamma. The whole idea of this project is to recommend movies to the users. At the same time, before jumping into the recommender system, we wanted to perform some regression analysis and classification. The regression analysis will predict the revenue of the movie, whereas the classification will see if a movie was a success or a failure. To proceed with the data set, this data set consists of 45,000 movies listed in the full movie lens data set, and it consists of 26 million ratings from 270,000 users for all the 45,000 movies, and the ratings are in a scale of 1 to 5. This data set is taken from Kaggle dataset. As part of data exploration, we performed some cleaning. We converted variables to desired data types, merged data sets, converted JSON data to meaningful values, did some dummies. We also re-engineered the features to meet our model expectation types. With proceeding with the EDAs, we checked for null values. Then we checked about what are the titles and overviews which are the most important words in them, and we found out love, girl, day, man, night. These are the most important ones in the title, and probably life, find, one, love. These are more used in the overview. So it's kind of we see more of like romance movies in the whole data set. Then we thought of checking like what countries with the most number of movie production, and we found out that United States of America is the most is a popular destination, and most of the movie production are done here. We can see in this pictorial representation. Then we thought of checking which companies makes the highest revenue, and we found out Warner Bros, Universal Pictures, and Paramount Pictures are the top three, with the top collections as like Harry Potter, Star Wars, and James Bond, which kind of makes sense. Then we thought of checking which movie, what is the which day the movie is released. So it's which month and which day. So we found out that in January and probably in September and October the most releases happen, and in Friday the most of the movies are released. Then the next point of check was to see which actor and director made the highest total revenue, and we found out Stan Lee and Steven Spielberg are the ones that makes most of the revenue in the dataset. Then jumping into the analysis techniques, we have our three lines of analysis, which is regression technique, classification, and recommender system. We performed different models for regression analysis, and they were like linear regression, random forest, ridge, lasso, and elastic net, and which we are at the end comparing and to see which model performs the best. Yeah, so linear regression, with respect to linear regression, we found a pretty good R square for the linear regression. With the RMSE, you see the highest, a bigger number in the RMSE, because our revenue is in billions, and here we are seeing millions as the error, which is pretty good. We also performed a cross-validation fold, which kind of saw a similar result. As part of the feature importance, we saw budget, popularity, and vote count as the most important features. There was some randomness in this in the actual versus predicted, the residual plots, and we did not see no trend in it. Similar approach was done for random forest, but we saw random forest was completely overfitting with a huge difference between the R square of the training versus the validation. We also performed some hyperparameter tuning to see if we could make it better, but it was still overfitting. With respect to ridge regression, we performed at alpha, we made a like parameter selection, and we found out alpha at 0.1, and we kind of saw pretty much similar result as linear regression. As part of lasso regression, we found out optimal alpha is 0.001 and saw pretty much same result as linear regression, with training R square 73% and validation R square as 76%. With elastic net, we find our optimal alpha at 0.001. We took LR ratio 0.5 and found out pretty much similar result like linear regression, with the training R square 73 again and validation 76% again, and we also saw some randomness in the residual plots. Finally, we are doing a model comparison, and we found out linear regression performing the best. We also did some feature selection with linear regression, but it did not turn out pretty good because we are dealing with money here. We wanted the best R square. So we took linear regression ahead and did the testing, and we found out the R square increasing to 78% and reducing the RMSE error.
Hi, I'm Eric from Data Crew, providing an overview of 4 different models to classify whether a movie will be a success or a failure. And those models are linear discriminant analysis, AdaBoost with decision tree as the weak learner, logistic regression, and random forest. And we are using 10 k-fold cross-validation with grid search for hyperparameter tuning. A quick overview of the data set. We have a class imbalance. Class 0 represents failure, and class 1 represents a success. On the right-hand side, we have 14 independent variables with 5,393 data points, which will normalize because of a wide range of values that exist. And we will be splitting the data set 80-20, training and testing with stratification. And this is a heat map of our correlation, and none of the features are highly correlated. These are 4 model metrics shown on the top compared to the rest of the models. AdaBoost performs the best overall from the training to testing. The bar graph represents the balance accuracy on the left-hand side, and on the right are the F1 scores for all 4 models, starting with AdaBoost, linear discriminant analysis, logistic regression, and random forest. It's hard to tell from the bar graph that AdaBoost performs the best with unseen data set. Finally, by examining the RC curve on the left and the precision curve on the right, we can finally confirm that the AdaBoost with a decision tree as a weak learner is the best performing model. We try feature selection using select percentile with a chi-square function running multiple iteration. Selection of features were widely different in every iteration, as you can see. Therefore, we used important feature with a 5% as a cutoff, which gave us k of 7 to be used in select k best, and utilized the f class F function. We use AdaBoost with the select k best features where k equals 7, and utilize model stacking by tuning the random forest. The tune value shown on the top right before stacking with AdaBoost. Also, there is a graphical representation shown on the lower right. The top bar plots represent the balance accuracy on the left and F1 score on the right. The first bar plot is select k best, followed by stacking classifier. At the bottom left, we have the ROC, and at the bottom right, we have the precision recall plot. Both models' performance are very similar, but it was concerning the area under the curve precision recall plot is almost 1. Finally, we try over and under sampling, and the random forest struggled with sampling. And AdaBoost model looks stable, but the gap between training and testing is a little bit wider. AdaBoost and random forest would have performed better if hyperparameters were retuned for the balanced data set. But interestingly, logistic regression showed 3% increase in performance in both over and under sampling, which was very surprising.
So now we'll proceed ahead with the recommender system. So in this, we have done 4 different types of models. The first one is a simple recommender system. There's content-based filtering, collaborative filtering, and hybrid approaches. So coming to the simple recommender system, this offers generalized recommendations based on movie popularity. So we have used the given formula to capture weighted rating, and based on that, we have given you an example run of the top movies in the world. So in any part of the world, you'll be getting the same top 10 movies. So going on to the next one, we have run it for different genres as well. So when you run it for genres, like romance, you get Dilwale Dulhaniya Le Jayenge. When you run it for animation, you get Lion King. And when you run it for ease action, you get Inception. So these are the top movies from all over the world. And doesn't matter which place you stay in, you'll be still getting the same results. So followed by this, we ran a content-based filter. So content-based filter is a recommendation technique that suggests similar items to users based on the experiences in the past. So first we ran it based on overview and description, and later on we ran it based on keywords. So when we can see an example in case of overview, when Batman movie was given, the following movies were given as suggestions, and when given based on keywords, similar movies were given but in different order. So followed by this, we went ahead to recommend something which will exclude the low quality movie and give a movies with high ratings and popularity. And while doing this and giving input as Batman, we see movies like Spider-Man 2 from the comic universe coming, Superman 2 showing up compared to the past filter. Followed by So coming to the next technique, collaborative filtering. Here we used SVD algorithm to predict the users' ratings for a specific movies. So we can see the SVD is performing very well with relatively low RMSE values and May values. Additionally, the algorithm demonstrates efficient performance in terms of both model fitting and testing times. Apart from this, we have also given two examples for for collaborative filtering, where user 1 and user 343 gives rating for a similar movie of Sunrise, a Song of Two Humans. We can see that user 343 has given a rating of 3.19 out of 5, whereas user 1 has just given 2.31 on a scale of 5. This is based on user preference, and that is how we got this scores. So the next technique that we have worked in is a hybrid recommender. So it basically merges content-based and collaborative filtering techniques to enhance recommendation accuracy and diversity. So based on user recommendations and the movies watched previously, for two different users, we have ran it and we have gotten the outputs which have been shown here.
To conclude with the analysis of our project, we saw the regression and the classification giving us a pretty good result in predicting the movie revenue and classifying the movie as a success or a failure, having consensus. Then we saw the recommender system giving us a pretty good model in recommending the movies to the user based on various parameters, especially the hybrid system. The future work for this project would be we would like to do some more intensive approach in each line of our analysis and getting the performance better. So we had a good experience in this project and would like to do something more to improve the performance. Thank you everyone.